The directions say to find the exact value of each logarithm without a calculator. Let's take a look at example 1. Suppose we want log base 2 of 256. So what we're going to do is set log base 2 of 256 equal to x. Now, I want to solve for x. So we can say 2 to the x is equal to 256. That's what I'm getting right here. Now, can I write each side so that they have the same base? And the answer is yes. So what I did was I started with 256. But 256 can be written as 16 times 16. But 16 is equal to 2 to the 4th. So if I take 16 and square it, that's 2 to the 4th quantity squared, which is 2 to the 8th. So 256 is the same as 2 to the 8th. So 2 to the x is equal to 2 to the 8th. And if 2 to the x equals 2 to the 8th, it follows that x must equal 8. So the correct answer to example 1 is 8. Suppose we want log base 10 of 0.001. Same thing as example 1. We're going to set log base 10 of 0.001 equal to x. So we can say 10 to the x is equal to 0.001. That's what I get here. And just like in the first example, can we rewrite both sides so that they have the same base? Well, 0.001 is equal to 1 over 1,000. And 1,000 is equal to 10 to the 3rd power. So 10 to the x is equal to 1 over 10 to the 3rd, which says 10 to the x is the same as 10 to the negative 3. And if I solve for x, I get x equals negative 3. So the correct answer to example 2 is negative 3. Example 3. Suppose I want log base 1/3 of the cube root of 243 divided by 27. So just like in the first two examples, I'm going to set log base 1/3 of the cube root of 243 over 27 equal to x. And so that says 1/3 to the x is equal to the cube root of 243 over 27. Now, we want to be able to rewrite both sides of this exponential equation to have the same base. That's the goal. Okay. Now, 27 is equal to 3 to the 3rd. 243 is equal to 3 to the 5th. And 1/3 is equal to 3 to the negative 1. So I'm taking literally everything piece by piece. So 3 to the negative 1 raised to the x, that's the left side, is equal to the cube root of 3 to the 5th divided by 3 to the 3rd. Okay, so all I did was replace that 243 with 3 to the 5th. I replaced 27 with 3 to the 3rd. I replaced 1/3 with 3 to the negative 1. And I get this bottom equation here. So we can say 3 to the negative x is equal to 3 to the 5/3 divided by 3 to the 3rd. Now, recall, this is a property of exponents. A to the m divided by a to the n is a to the m minus n. So 3 to the negative x is the same as 3 to the 5/3 minus 3. And then just off to the side here, I wanted to figure out what 5/3 minus 3 is. And when I do that, I end up with negative 4/3. So you notice I just get a common denominator. I rewrote 3 as 9/3. And so 5/3 minus 9/3 is -4/3. So 3 to the negative x is the same as 3 to the -4/3. So notice how I rewrote both sides to have the same base. So it follows that negative x is the same as -4/3. Divide both sides by -1, and we can see that x equals 4/3. So the correct answer here is 4/3. That's example 3. Let's take a look at example 4. Suppose I had log base 5 of log base 3 of 3. So notice I need to figure out what log base 3 of 3 is. I work inside, outside. So I set log base 3 of 3 equal to x. Notice how I'm doing this off to the side. So it follows that 3 to the x is 3. Solving for x, we get x equals 1. Notice that 3 to the first is 3 to the first is 3. So notice x is 1. And so we can write this as log base 5 of 1. And off to the side, I set log base 5 of 1 equal to y since x is taken. So 5 to the y is equal to 1. And so y is 0. And so log base 5 of 1 is equal to 0. That's example 4. Example 5. I'm going to do it much the same way. If I have log base 3 of log base 2 of log base 2 of 256, I'm going to work inside, outside. And we already figured out what log base 2 of 256 is. And from example 1, that's equal to 8. So on the second line, I'm going to say this is equal to log base 3 of log base 2 of 8. Now, I need to figure out what log base 2 of 8 is. So I'm going to set log base 2 of 8 equal to x. So 2 to the x is equal to 8. So 2 to the x is equal to 2 to the third. So x is equal to 3. And so this is equal to log base 3 of 3. And you can see from off to the side that log base 3 of 3 ends up being 1. And that's how we do example 5. Let's take a look at example 6. So we'll do one more example for this video. Suppose I ask you the following. Suppose I had log base 1 over root 3 of 3 plus log base square root of 3 of 9 plus 3 raised to the log base 3 of 2. Now, what we're going to do is we're going to take one term at a time. So I'm going to look at the first term here. And so I'm going to set log base 1 over root 3 of 3 equal to x. So 1 over root 3 to the x is equal to 3. But square root of 3 is equal to 3 to the 1/2. Okay? So 1 over 3 to the 1/2 raised to the x is equal to 3 to the first. So 3 to the negative 1/2 to the x is equal to 3 to the first. So 3 to the negative 1/2 x is equal to 3 to the first. Now I can set the exponents equal. So negative 1/2 x is equal to 1. And then what I'm going to do is multiply both sides by negative 2. And when I do that, I'm going to get x equals negative 2. And so, therefore, log base 1 over root 3 of 3 is equal to negative 2. Next term, set log base root 3 of 9 equal to, we'll call it y. So square root of 3 raised to the y is equal to 9, and the right side is 3 squared. And then we get 3 to the 1/2 raised to the y. Now, when you have a power raised to a power, you multiply the exponents. So 3 to the 1/2 y is equal to 3 squared. So 1/2 y is equal to 2. So what we're going to do is multiply both sides by 2. And then when we do that, we get y equals 4. And so, therefore, log base root 3 of 9 is equal to 4. So it's a little long, but we got one more for you. Now, this last one is short. So if I have 3 to the log base 3 of 2, I claim that that's equal to 2. Now, if we come back, we get to put it together. So we'll put it down here. So if we recall, now 3 to the log base 3 of 2 is 2. That's the second one here. Log base root 3 of 9 is equal to, let's go back. That's equal to 4. So I'm going to put a 4 here. And then log base 1 over root 3 of 3, if we come to the other side, I got negative 2. So I'm going to put a negative 2 here. And notice how negative 2 plus 2 is 0, so those terms cross off. And so the correct answer here ends up being 4. And that's example 6. And that'll do it for this video, where we found the exact value of logarithms without using a calculator. Thank you.